Hello, my name is Liam Marrison, and for my Grade 12 Advanced Functions Math CCT, I've been provided with question number 8 on page 361 of the Nelson Advanced Functions textbook. So, my question states that a contestant on a game show spins a wheel that is located on a plane perpendicular to the floor. He grabs the only red peg on the circumference of the wheel, which is 1.5 meters above the floor, and pushes it downward. The red peg reaches a minimum height of 0.25 meters above the floor and a maximum height of 2.75 meters above the floor. Sketch 2 cycles of the graph that represents the height of the red peg above the floor as a function of the total distance is moved. Then determine the equation of the sine function that describes the graph. Okay, so clearly the question here is asking us to use the information provided to make a graph that demonstrates the cycle of the wheel being spun, and then we're going to have to find an equation for it. Alright, from looking at the question, I was able to determine that it is extremely similar to the application wheel questions from Unit 4. After reviewing my notes from the unit, I've been able to break down the question piece by piece and solve for the final answer. So right from the very first sentence of the question, we understand that it is a wheel question as it is clearly stated. The next sentence tells us about the starting point for the graph because it says the red peg is located at 1.5 meters above the ground and is where the contestant begins to spin the wheel. We understand that the graph is going to be starting in a downwards direction, traveling towards the x-axis, because the contestant spins the peg downwards. Next, we come to the realization of the maximum and minimum values of the graph, due to them being provided in the question. In the question it says that the maximum value is 2.75 meters above the ground, and the minimum value is 0.25 meters above the ground. And in the question there is no period provided for the cycle of the graph, so we have to assume that the length of one cycle is over the course of pi. Okay, I like to start things off by using a diagram before actually solving the question. So as you can see here, I've just kind of drawn the circle that's being the contestant's wheel, and then I've labeled the maximum and minimum values. Here you can see 2.75 being the max, 0.25 being the minimum, and then in the middle there you have 1.5 meters being the middle point where the contestant begins to spin the wheel, and then the value that I've drawn in between the maximum and then the middle value is the amplitude. And the amplitude is the height from the mean or rest value of the function to its maximum or minimum. And it's just the maximum value subtracted by that middle value. And that's how you get your amplitude, which is also our A value. Okay, so given the information we have taken in, we are actually able to graph this problem. We're able to graph the cycle of this wheel. So as you can see here, our starting point is at 1.5 meters and 0. So it's at 1.5 on the y-axis and 0 on the x-axis because it is our starting point and has not moved yet. So 1.5 meters is actually the equation of axis because it is the middle value. So as you can see here, our graph is obviously going to start off in a downwards direction because that's the way the red pin is going right from the start. It's traveling downwards and then going all the way back up again. So the graph makes sense because at 1.5 meters being the equation of axis, in this case, and the middle point, the red peg's going all the way down to the minimum value being 0.25 meters, and then going back up to the middle point, and then back up to the maximum value, which is 2.75 meters. So if you think about it in terms of the wheel actually moving, the graph makes sense because the wheel starts going downwards, reaches its minimum value, comes back up, hits the middle, and then reaches its maximum value. So in the graph here you can see we've done two cycles of the wheel, and over the period length is over the course of 2 pi for one cycle, because when you're not given the information about that, you have to assume it's 2 pi. And so the domain for this graph is clearly, for our domain, we're going to do x belongs to the set of reals, because the graph can just be continuous going down the x-axis, and x can be any value. Now, for the range, it's different, because as you can see, the y values can't just go on both up and down forever. That can't happen. So 2.75 is our maximum value, and y has to be less than that, because as you can see in the graph, it never goes above 2.75. And then our minimum value is 0.25 meters, and as you can see, the graph never goes past 0.25 meters, it never goes below, it always goes above. So clearly our range here is that y has to be greater than 0.25 meters but less than 2.75 meters. Okay, so now that we've actually graphed the cycle of the wheel being spun, now we can determine the values and create an equation. So first things first, that we know our A value is 1.25 meters because it is the difference between the maximum value being subtracted by the middle point. And then first thing we need to understand is that the sine graph is negative. Now, the sine graph is negative because it starts going off in a negative, it starts going off in a downward direction, making it negative. So our A value has to be negative. So even though the maximum value subtracted by the middle point is 1.25, we have to make our amplitude negative 1.25 in order for the graph to go in a negative direction to start. Okay, and so our B value in this case is 1. In the question, we have to assume that the period is 2 pi because the length of each cycle is not provided within the question. To determine the B value, you have to divide 2 pi by the period, which in this case is 2 pi. So therefore, 2 pi divided by 2 pi is simply equal to 1. Okay, and for our H value here, it is actually not applicable. There is no phase shift. And a phase shift is when, say the sine graph started off in a different area, like it didn't start off in the middle point, it started off at the maximum value, then there would be a phase shift because you'd have to move the graph over to have it be where it should be on a normal basis, right? So in this case, our graph starts off on the middle point, so there is no H value because there is no phase shift or movement of H. And then for our K value here, the K value is always equivalent to the equation of axis, which in this case is 1.5 meters. So our equation is just simply negative 1.25 sine x plus 1.5 because our B value is 1, so it doesn't actually have to be in the equation itself, and then we have no H value, so it's just sine x instead of sine bracket x minus our H value because it's not applicable. Okay, so that's how you solve the question. Thank you so much for listening, and if you're interested in a potential career where you can be using sine and cosine graphs, the music industry is actually very prominent towards that. If you want to become, for instance, a composer, music is composed of waves of different frequencies and amplitudes, and these can be described using sine and cos graphs. Okay, thanks again so much for listening. Once again, my name is Liam Marrison, and my question was on page 361, number 8 of the Nelson Advanced Functions textbook. Thank you.